Hello everyone, welcome back. So this time we're going to try an example out. We have two identical 10 kilogram spheres, right here and right here, and they're attached to this rod which rotates in the plane of the page. Now the spheres are subjected to a tangential force of 10 newtons, and the rod is subjected to a couple moment of 8t newton meters, or t's in seconds. It says we want to know the speed of the spheres at t is equal to 4 seconds if the system starts from rest. Okay, we're going to go ahead and do this one together, though if you want to, you can always pause it, because the equations we saw last time, sure, we've seen things that are similar to them, but they're not necessarily easy to deal with. So let's do them together. So we're going to apply the principles of conservation of energy and conservation of angular momentum to the system to solve these equations. Okay, first off, conservation of angular momentum. We know that the sum of our moments over this time frame will then be equal to the time rate of change of our angular momentum. And so if we integrate it, well, we can figure out how much our angular momentum changed during this time frame. So we have two things that are causing our two components for momentum. One is just from the equation they gave us. The second is because, well, we have a force, a constant force that's being applied, and that is also going to be causing a moment constantly. So if we then integrate that, we get this right here. Now this right here is talking about our angular momentum at the end. We don't know where our velocity is, but we're not just trying to solve for the angular momentum, we actually want to solve for our velocity at this final time frame. And so we know that this one, angular momentum, will be equal to its momentum times the arm. The arm doesn't change, it's 0.5. There's two of them, that's why there's two. Its mass is 10, and so to get momentum we multiply mass by velocity, which is why we had that last component. So we integrate everything, and then we solve, we get our velocity at this end of our time frame will be 10.4 meters per second. Yep. So that is it for this time. It's a very simple problem, but you just have to see how you do this. So we add all of our different moments together, and then we integrate them. And that will be equal to how much our angular momentum has changed. Thanks for listening. I'll see you all next time. Bye-bye.